Hello, good morning everyone. Today we will discuss about the thermochemistry. Please see my presentation below. Okay, thermochemistry. In this topic we will learn about heat and energy, exotherm and endotherm, chemistry equation, standard enthalpy changes, and determination of enthalpy changes. Okay, first slide, heat and energy. The first point is about the system. System is something that we observe, something on the reaction. Whatever inside the reaction is belong to system. And then we have lingkungan or surrounding in your person bulk. It is the part of outside the system. So let if you have reaction on the tube, like you put natrium on the water in the flask or in the tube, so the water and the natrium and the place, the container, it is the system. And whatever outside the system is belong to lingkungan, like the air, the situation, the temperature, that's belong to lingkungan. The next one is energy. So all matter in this world have energy because of what? The most smallest part from the matter is the atom. An atom have electron that always move and they have energy. So that is the proof that all the matter have energy. Like when electron jump to the other atom, they can emit energy or absorb the energy. And in chemistry, the energy that in the matter we just see from the heat. Okay, this is based on the law of thermodynamic one, that is energy cannot be changes. Energy can be changes, but cannot be destroyed. The heat is used for the reaction in constant pressure. We call it as enthalpy. The enthalpy cannot measure, but we can measure the enthalpy changes. The enthalpy changes, we call it delta H. Enthalpy is H. So delta H we can see from the differences or the gap from the enthalpy product and enthalpy of reactant. Okay, next one is if we talk about exotherm and endotherm. We have two kind of reaction in the thermochemia. So exotherm is reaction that uh, have these three parts. The delta H is negative, the temperature is increasing, and they have released the heat to the surrounding. If you see from this picture, the heat or color from exotherm, they transfer out to lingkungan. And for endotherm, the heat as the energy and the color they are transferred into the system. The second picture is about diagram enthalpy. Diagram enthalpy is like a diagram that shows the energy on the ordinate. So we can see from this graph there is reaction or reactant. We have hasil reaction or product, and then we can see from here is the energy or enthalpy from reactant, and in here we have the enthalpy or energy for product. We can see that in this diagram enthalpy product is higher than reactant. So the delta in here is positive because increase. So in this part we can see that this is endotherm reaction, and this one the other way. When they have enthalpy is decreasing, we call it as endotherm. Just be careful with enthalpy and temperature, because in here the temperature is increasing but the enthalpy is decreasing. Okay, so three parts that almost same, but usually people confuse in this part. For me, I usually memorize with one thing first. So like exotherms, delta high always negative, and the temperature is always increasing. So tambah panas, and then there is releasing heat to the surrounding. The easy example from the exotherm is burning. Kita bakar sesuatu, itu masuknya ke exotherm. And then endotherm is the other way. Next is thermochemistry equation. How to write the chemistry equation? It's the same with the reaction equation like you did on the grade 10. But in this thermochemistry equation, they have enthalpy changes. So you can see from the example. We have A plus B plus C and delta H plus X. Let's say like that. 3 points, the most important part on this topic. First one, the reaction must be equal. When the reaction is multiplied, and then the enthalpy changes. Wait. Here, you can see from the example, we have the same reaction, only different coefficient, and you can see the enthalpy much different. Second one is the pace. Different pace, also different enthalpy. You can see from there, if you have the same, now the reaction is the same, the coefficient is the same, but only the pace is different, and the enthalpy also different, so be careful. And then the number 3 is the sign on the enthalpy. That is negative sign, and sometimes we have positive and sometimes without symbol. Negative sign, it means that is reaction of exotherm. Positive or without symbol, it means there are endotherm. Okay, we'll continue the next part. So we will talk about example of enthalpy changes. So basically all the reactions have the delta H. They have enthalpy changes. And then we have naming some reaction based off the kind of reaction. Let's say there is enthalpy changes of formation. There will be decomposition and a lot of example. And oh yeah, we have standard here. So standard here is the condition. So standard enthalpy changes, it means that enthalpy changes is measured on the certain temperature, certain pressure. So they have standard temperature and pressure, 25 degrees Celsius and 1 atm. Some reference, they put it in on the Kelvin and Joule. Joule, sorry, Pascal. So how to convert from Celsius to Kelvin is just add 273. So become 298 Kelvin, and from atm to the Pascal is just multiply with 100,000. So 100,000 Pascal or 100 kilopascal. So that is just like information for you, the reason of standard. And then let's continue with the kind of enthalpy changes. The first one, we have enthalpy changes of formation or delta HF. So that is the enthalpy changes when 1 mole of compound is formed from a stable element under standard condition of standard state. Why I have to hold some word, because this is the most important part. So there is 1 mole form, so only one on the right side, and then the left is the stable element. You can see from the example. So on the right side there is only 1 molecule, because this is the formation reaction. So only 1 molecule on the right side with 1 coefficient. 1 coefficient is mean 1 mole. They cannot be 2, because with 2 the delta H will be different again. Just remember in the previous slide. And then the left side, that is the most stable element. On the left side, because the water is formed from hydrogen and oxygen, you cannot write only H or O, because H is stable on hydrogen, H with 2 index. Number 2 is index, right? So you have to know the how to say 2 is index, and 1 per 2 on that part. In this one, it is, we call it coefficient. This is index, this is coefficient, this is the base. Okay, so this is the example. Next, we have standard enthalpy of decomposition. Because of decomposition, the symbol is delta H. It is delta H to break down 1 mole of compound. Break down 1 mole, again 1 mole. So only 1 from, because decomposition, penguraian, so the compound will be on the left side. You can see from the sample. So NO2, jadi N2 nya setengah plus O2, itu ada delta HD nya. Terus on the right side, nitrogen will be N2, not only N alone, because they are maybe some of you will have a question like this: how we know they are in N2 or only N, or what kind of atom that's stable with index 2, I can say that most of the non-metal will be on the like that. But if you have metal, they will stand alone. Like natrium, they will stay as natrium, not natrium 2, not sodium 2, lithium as well. Next is combustion. Combustion is pembakaran. So if you remember what is the burning, it means there is a reaction with oxygen. Again, one mole compound that burn it. So in that case, C2H, so that is ethana. When we burn it, they will produce CO2 and H2O. All the carbon will produce CO2 and all the hydrogen will produce the water. And then you have to adjust the coefficient. The most important part, how to balance the reaction, just to remind you, please balance all the atom except hydrogen and oxygen. So hydrogen and oxygen is the last priority if like this. So you have to balance the carbon first, or maybe if you meet the other atom, you have to balance the other atom. Sorry. Next, standard enthalpy changes of neutralization. Neutralization is process to react from acid and base to produce the salt and water. So you can see from the example, there is an NaOH as the base and then HCl for the acid. They will produce an HCl as the salt and water. And that one is the delta H. And again, 1 mole, so the coefficient is must be 1. Okay, so that is the 4 kind of example enthalpy changes that usually use it. Actually, many reference tell us about this other example like the solvation, atomization, what again? Yeah, a lot of them, but at least you know about this four is more than enough. Okay, okay. So this is the end. I think you will work on this exercise. 5 question. I will try to little bit hard to work on this question. The first one, you have uh, reaction equation. So from that you have to check first that this balance or not. And then you have to find out the system, lingkungan, and transfer energy. Transfer energy means exotherm or endotherm. And then number 2, that is about the same question. You have to find out the system and the lingkungan. You can try to work on it. And then number 3, you have delta H. You have to decide how is the thermochemistry equation from decomposition and the forming. And then under number C, we have formation for formal C2H4 ethana. So be careful with the delta H. Here we have this number and then 4 mole. So it means you have to multiply this one because we need 4 mole, not only 1 mole. Okay, number 4, they have reaction. And then you have to decide this is exotherm or endotherm. Because of why, here there is blue. So you can decide. And how about the enthalpy? You can explain on there. And then number 5, we have combustion reaction, and this is the enthalpy. You have to decide the delta H and write down the equation. But be careful, this is not the delta H because of this one only for 1.6 gram. You have to find out 1.6 gram is how many mole, and then this is only for that mole. And you have to find how if there is 1 mole, so how many in the color, the heat, or the delta H. So that is used for the answer number 5. Okay, that is all from me today. So the next one we will discuss about how to find the enthalpy. Thank you.